So the very first thing we start with is actually what y'all saw me setting up for Algebra 1. It's the very first thing any algebra book typically starts with. It's sets of numbers. The sets of numbers that encompass really all numbers except for imaginary. These are your sets of real numbers, which is why it says it that way. Natural, whole, integer, rational, and irrational all fall within your real number set. Natural numbers, those are your counting numbers. It's what you learn when you're like 1 and 2, 1, 2, 3, 4, 5, 6. If you can count it, it's in the natural numbers. What it does not include is 0. So 0 is not a natural number because in the natural world, you're counting, you start with 1, like if you're trying to count something. So those are your natural numbers. Whole numbers are all your natural numbers, but then they just bumped in your 0. 0, 1, 2, 3, 4. You see the ellipsis there, the dot, dot, dot. It's because it goes on infinitely. Integers, those are your whole numbers and their opposites. Now 0 doesn't have an opposite, but all of your other integers, all of your other whole numbers do. So it not only includes the 1, 2, 3, 4 on the right side of 0, it also includes the -1, -2, -3 on the left side of 0. And then you get into rational numbers. Rational numbers are any number that can be written as a fraction. So what you start seeing here is you start seeing a pattern of them being included in the next set, because any whole number can be written as a fraction. 3 as a fraction is 3 over 1, right? What you can't write as a fraction is an irrational number. They define it by non-repeating, non-terminating decimals. 1/8, that is a terminating decimal. 1/3 is a repeating decimal. Those both are written as fractions. What cannot be written as a fraction is square root of 2. If you put square root of 2 into a calculator, it will give you a number that ends, but it's because your calculator is not infinite. It's actually rounded that number. And if you get a bigger calculator and put in square root of 2, it's actually going to keep going with that number because that is an irrational number. That decimal never ends. The one we're really, really familiar with is pi. Pi is an irrational number because 3.14 is how we round it, but it keeps going, right? 17, blah, blah, blah. We have people that just enjoy memorizing thousands upon thousands of decimals with pi, whatever. But the truth is that it is non-terminating, non-repeating. The digits, you'll see a digit appear again, but what it means by repeating is repeating in a pattern. Pi doesn't repeat in a pattern, it is an irrational number. And so those are the examples you will typically get. All right? All of those are falling under the umbrella of a real number. We are going to do imaginary numbers this year, but this is real number sets. And so they've given you this really nice chart that shows you how they fit nicely into each other. Sometimes you'll see it done in a Venn diagram setting, and this is similar to that. Natural numbers, that's your basic. But whole numbers include your natural numbers. Integers include your whole and your natural numbers. Rational, integer, whole. And so you see this, and all of these fall under the umbrella of real, okay? And so that is your number set that you're going to first see. So the first thing they ask you in example 1 on the next page is, where do these numbers fall? Real world settings. Many mathematical relationships involving variables are related to amusement parks. So they've used an amusement park theme here. Which set of numbers best describes the value for each variable? The first one is the cost C in dollars of admission for N people. All right, dollars, how do we write dollars? Like in what set? Do I have to tell you how to round if it's something in money? Should I have to tell you what decimal place to round to if it is in money? No. What is it going to be always? 100. Yeah, hundredth. Well, you just gave me decimal places, right? So what does that have to be? So, and something else to ask, decimal. If it's money, that's always over what? 100 is what you just said. Why? Because we have 100 pennies in a dollar. So we know it's terminating, but we also know it's a decimal. Any money that you're given, you should be able to write as a fraction because you could put those cents over 100 and you just created a fraction. So which set of numbers would that fall into? Rational numbers would be any number that can be written as a fraction, all right? Your integers do not have decimal places. Your whole numbers do not have decimal places. Your natural numbers do not have decimal places. The first place that you see a decimal is your rational numbers. These are all terminating decimals. They can all be written as a fraction because all of your cents are over 100, which just told me it can be written as a fraction. So this one would be rational, right? And they gave you that explanation there. The maximum speed S in meters per second on a roller coaster of height h in meters. And they give you the formula in the left-hand side. If they want to find speed, you're going to use this 1200 over the square root of h. 1200 over the square root of h, all right? Right here. What do you think here? Kind of a tricky one, because if you end up, there are square roots that actually are perfect. Square root of 4, for example, okay? So if my height is 4, then I'm good. My height is actually going to be a rational number because it's a measurement in feet. So I'm either going to have a foot or a fraction of a foot, right? So my height is definitely a rational number here. Now my speed, on the other hand, could be irrational. It could be rational depending on what my height was. If my height is something that does not have a perfect root, then I'm going to have an irrational number in there, right? And so then all of a sudden it throws it out. And so it depends. It actually depends on what it is. Look at the last one. The park's profit in dollars for each week of the year. Once again, dollars is going to be what? Rational. Any questions on this? Questions on doing it? Let's look at graphing. This is a lot going on here. Let me did. So we'll just delete these guys here. There we go. All right, graphing. So if I graph numbers, what I'm looking for is, do you know where it is placed? Okay. So for example, -3/2. If I want to graph this particular number, I'm not going to say, well, they don't know, I'm going to measure halfway in between this and that and make sure that you got it exactly. That's not what I'm looking for. I'm looking for, do you know where it should fall? And so if I have a number line here, and I'm just going to put my numbers, right? Negative numbers, positive numbers. Do I know where it would fall? And so for this, you're going to say, where would -3/2 fall? If you don't know, make it a mixed number, right? -3/2 is a mixed number is what? -1 and -1/2. So it's going to fall between what two numbers? 1 and 2. -1 and -2, right? -1 and -2. So -1.5 or -3/2 should be about right here. All right. 1.7 repeating. Where is that going to be? Be what between the 1 and 2? Probably somewhere over here, right? 1.7 repeating. What about square root of 5? So here's what you do with square root of 5. You find the two numbers on either side of it that have a perfect root. So less than 5. What's the first number less than 5 that has a perfect root? 4. Okay. Where is square root of 4? 2. At 2. So this is square root of 4. All right. What's the number directly to the right of 5 that has a perfect root? 9, right? What is the square root of 9? 3. So it is going to fall somewhere between the square root of 4 and the square root of 9, probably closer to the square root of 4 side, right? Mm-hmm. And so, and I put 1.7 here. That goes there. Did no one want to tell me that I put it here?
I saw it wrong, so I didn't say anything.
Sorry. There we go. So it's going to fall more, and I still put it in the wrong place.
1 and 2.
Yeah, thank you. I'm drawing my own thing wrong. All right. So yeah, it is going to fall closer to this side right here, square root of 5. All right. All right, so when you're looking at a number line, you're just saying, do I know where it falls in between? And so mixed numbers or finding the closest roots is going to help you do that. So go ahead and try graphing those three numbers. See, did I move it? So when you're doing your square roots, if it has a root, you can take the root and you can see it. If it doesn't, you can literally compare what's inside, because those two are going to translate to greater than less than based on what it is. The tricky part of this is your negatives. So your negatives flip-flop greater than less than, right? That's what happens when you multiply or divide by a negative. It flip-flops your sign. That's what also happens here, because you're looking at distance away from 0 on the negative side. The further away from 0 you are on the negative side, the smaller it is. Whereas on the positive side, the further away, the larger it is. So those actually relate that way. All right, the next one. So you will have terms just like in geometry. They're bold and they're highlighted, all right? I, however, am not going to give you a list of terms on your test. However, on your test, if I say find the additive inverse, I am also not going to tell you what that means, all right? So while you don't have to like write out the definition, you need to know it in terms of if it is given to you in instructions, all right? Additive inverse really just means opposite, all right? If it says find the additive inverse, it means find the opposite. Think of it in terms of an equation. Additive inverse, okay? What that basically goes to is in an equation, when I have to move something to the other side, I change the sign, right? Because I am adding the inverse to get it across the equal sign, right? Because if I add the inverse, they cancel out. That's what additive inverse means, and that's what I'm trying to do in an equation. Same thing with multiplicative inverse or reciprocal, all right? Multiplicative inverse just means dividing by, multiplying by the reciprocal, okay? Multiplicative inverse. In an equation setting, if I have 3x equals 6, the reason I divide by 3 is I am actually taking the multiplicative inverse to cancel it out on that side. In the additive inverse, it makes it 0. -3, +3, 0. Multiplicative inverse makes it 1. 3 times 1/3 equals 1, okay? And so opposite, additive inverse, that's the same thing. Reciprocal, multiplicative inverse, that's the same. When you add the opposites, you get 0. When you multiply reciprocals, you get 1. And that's how we start moving into solving equations. We do those things so that we can eliminate things on one side so that we can solve the equation. And that's where these terms come from. So finding the inverse, find the opposite and the reciprocal. Now, reciprocals do not change the sign, okay? So there are occasions where you use the negative reciprocal, but reciprocal itself does not flip the positive negative. The only thing that flips the positive negative is the additive inverse or the opposite, okay? So if I were finding the opposite of -3.2 or the additive inverse of -3.2, all I have to do is change the sign of it, the positive negative, right? So this one would be +3.2, right? If I want the reciprocal here, now reciprocal is a little bit different because they typically don't want the reciprocal in decimal form. They give it to you in both as the answer. So you really want to write it as a fraction. All right, so how do I write -3.2 as a fraction? Or I could say 32/10, so 3 2/10, right? Does that make sense? So you can put the whole thing over what your decimal place setting is. 0.1 is in the 10ths place, which means 32/10 is going to be 3.2, right? You can always just put your denominator as whatever your place is for how many decimals you have, okay? Now, you can also reduce this. What goes into 32 and into 10? 2, right? So I can actually reduce that to -16/5, right? And that won't reduce anymore. Now, it's very easy to see what my reciprocal or my multiplicative inverse will be. What is my multiplicative inverse here? Yeah, -5/16. And when you're talking about fractions, your negative applies to either or, which is why it goes in front. So you typically put the negative in front of the fraction that you're talking about. But that comes into play with slope, all right? 3/5 is easy. Opposite of 3/5 is -3/5. Reciprocal of 3/5 is 5/3, right? Just flip it. So do those 4 really quickly. By the way, when you do a reciprocal of a mixed number, change it to an improper fraction first. Don't just flip the one piece of it. That is not a reciprocal. You have to have an improper fraction before you flip it. So this is also an Algebra 1 concept that we covered. It's in the middle of page 7 in your books. So all this is doing is moving you towards equation solving. which we're going to jump right into in the next sections. But so closure, what closure tells you is that with addition and subtraction, if you add two real numbers, you're going to get a real number. If you multiply two real numbers, you're going to get real numbers as your answer. That is a closed set of numbers. You're never going to add two real numbers and get an imaginary number. That won't happen. In order to get an imaginary number, you have to add a real and an imaginary, or add to imaginary. You will not fall outside of your set of real numbers if you add two numbers that are already in your set. That's what closure means. Commutative property is true for addition and multiplication. It is not true for subtraction or division. Only addition and multiplication, meaning order does not matter. If I add 2 and 3 or 3 and 2, I get the same answer. That's not true with subtraction. 2 minus 3 and 3 minus 2 do not give you the same answer, right? Same thing for multiplication. 2 times 3 and 3 times 2 are the same. It does not work for division. 2 divided by 3 and 3 divided by 2 are not the same number. So these properties are all only true for addition and multiplication. Associative property. Associative property says that parentheses don't change it if it's all addition. So parentheses are important and order is important when you talk about order of operations. But if you have all addition, order of operations is kind of out the window because it doesn't matter what order you add it in, which is commutative. It doesn't matter if you have any grouping, which is associative. All right. Same is true for all multiplication. We learn order of operations, PEMDAS, but the truth is if it's all multiplication, you can switch those things around to make it easier if you need to. Identity property. If you add 0 to something or multiply something by 1, the number doesn't change. The identity of the number doesn't change. Inverse is what we just talked about. If you add an inverse, whether it be addition, you're going to get 0. Multiplicative inverse, you're going to get 1. The caveat there is that it can't be 0. 0 does not have an inverse because you can't divide by 0. So other than 0, that works for everything. Distributive property. This is a multiplication property, but it actually applies to the two combined. If I have a number on the outside of my parentheses, I can either add those first and multiply, or I can distribute that multiplication to everything within the parentheses. So let's look at which property is illustrated here. I have 6 plus negative 6, and I get that it equals 0. Which property tells me that? Which property says if I add these two numbers that are related somehow that I get 0? Yeah, inverse property. I heard it a little bit. Inverse property, right? Those are inverses of each other. If you add inverses, you get 0. What about this one? They're saying that negative 4 times 1 minus 2 is the same thing as negative 4 times 2. What changed? What changed from the left hand of this equation to the right hand? They replaced negative 4 times 1 with what? Just negative 4. What tells you can do that? They didn't distribute anything. Negative 4 times 1 equals negative 4. What tells you that that is the truth?
It's identity.
Identity. Multiplying times 1 doesn't change the identity of the number. So instead of having that parentheses there, you can just write the negative 4. That's the identity property right there. Do those two on your own. Which property is illustrated? Which property is illustrated for the first one? 3 plus 0 minus 5 is the same thing as 3 minus 5. Yes, so if I add 0 to a number, I get that same number. That's identity. What about this next one? Negative 5 plus 2 plus negative 3 is the same thing as negative 5 plus 2 plus negative 3. What did they change there? Yeah, they changed the grouping, which is associative. Sorry, my iPad's about to die on me. Absolute value. So absolute value is the distance from 0 on the number line. The reason we're talking about distance is because it's always positive. So absolute value is always positive because they are telling you a distance, all right? If I say I am 6 feet away from Kelsey, I'm not going to say positive 6 feet away and she's negative 6 feet away from me, right? Positive and negative indicates direction, not distance, okay? That's why in football you gain yards and you lose yards. They don't say, oh, he just gained negative 3 yards. No, he went 3 yards away from his goal, which was the wrong direction, okay? And so positive and negatives indicate direction. Distance is always positive. Absolute value is talking about distance. It is always positive, all right? When you have something like -4, the distance away from 0 is 4. While it's on the left-hand side of the number line, it's still 4 away from 0. Just like +4 is also 4 away from 0 on the number line, okay? 0, well, that's easy. 0 is 0 away from 0 on the number line, okay? When you have something inside your absolute value, you need to do that process first, whatever it is, and then decide what your absolute value is. So I have -1 times -2. That's +2. The absolute value of that is going to be 2. It is 2 away from 0, all right? So absolute value just represents distance. Simplify. So simplify the absolute value of -10. 10. Simplify the absolute value of 1.5. 1.5. Simplify the absolute value of 0 minus 3. That's going to be absolute value of -3, which is 3. All right? For what values of x does the absolute value of x equal -x? When does the absolute value of x equal -x? When is that true? Let's illustrate this, all right? Let's say my x value is -3, okay? So for all x's in this equation, I'm going to plug in -3, okay? So I'm going to say then -3 here and -3 here. What does that say? What's the left-hand side equal? 3. What does the right-hand side equal? 3. So that is true for all negative numbers. The absolute value of a negative number is going to be the opposite of the number that's inside. Remember, negative just means opposite, right? So if I put a negative number in absolute value, it will be the opposite of what I just put into the absolute value. So that's true for all negative numbers.